Let me ask some question. Starting from the last, Sarah, what is the spin only formula? I'm asking from the previous classes, what is spin only formula?
Uh, the root of
Spin only formula
n to
is
n plus
used to calculate magnetic moment, right? And based on magnetic moment, you can tell whether a compound is paramagnetic, diamagnetic, or ferromagnetic. So this magnetic moment is n n plus 2 Bohr magneton, correct? And we already solved a lot of question. It's just a quick revision. We did this. Jordan, what is n in this case? बस थोड़ी ना business इतना नहीं. Jody.
So the yes,
Yeah. What is n?
lone pair.
No.
No.
unpaired electron.
Unpaired electron.
Oh, okay, yes, sir.
N is unpaired electron. So whatever you will do, example, if you are taking n value 3, then you will multiply 3 with 5 because 2 extra. N plus 2, na? If you take like 5 unpaired electron, then you will multiply by 7. Why? Because you are multiplying n with n plus 2 value. Understood? So we did this. Samarth, are you there?
Yes, sir, yeah. I'm there.
So tell me why copper have positive electrode potential.
So, electrode potential is decided by three factors.
Hmm.
So, in that, last factor is hydration enthalpy.
Hmm.
And in ionized form, copper, like, the hydration enthalpy is very negative. Like, it gains a lot of energy. So,
Hmm.
that will overcome whatever the energy was required for ionization of two electrons.
Main reason, if like we are doing lot of stuff and then you get confused, the main reason that you need to know is ionization enthalpy. Okay, if any value is positive, majority of time reason will be ionization enthalpy is high. If it is negative, ionization enthalpy will be low, because you can't simply tell hydration enthalpy easily, right? You It will be difficult to tell sublimation energy also, though we know electrode potential is decided by three factors. One will be sublimation energy, second ionization energy, and third will be hydration energy. These are the three factors, but you are not sure about these two, sublimation and hydration. So which factor will decide your value according to this chapter? Ionization. If any value is positive, ionization enthalpy is high. Value is negative, ionization enthalpy is low. Then automatically hydration will take upper hand, because these two contribute the positive value and hydration enthalpy is responsible for the negative value. Understood?
Yeah, sure.
So how many of you there? I think one of the person is missing. There are 7 people. Pratigya, Chandana, Jordan, Samarth, Tania, Sarah, Barinder. See, I was thinking like there were 7 people. So, come to the oxidation state. Though oxidation state is not one of the biggest topic because it takes very less time, but oxidation state is one of the important factor. And only question asked is which oxidation state is stable in a given element. Okay. And if you see scandium, the main oxidation state will be +3. If you see zinc, last one, only oxidation state will be +2. Correct. So at the end, you have limited oxidation state +3 or +2. Okay. But in the middle, if you consider manganese, manganese can show up to +7. Chromium can show +6. You have very high oxidation state in the middle. And not only +7, it could be +6, +5, +4, +3, +2, not less than 2. Correct? So you will see one of the common oxidation state that is present in all is +2. It is present in every element. Every single element have at least this +2 oxidation state. Scandium is one of the exception for sure, but all other element have +2 oxidation state. Same here, chromium is shown by many oxidation state from +6, +5, +4, +3, +2. But I am marking this. Why these two? Because +6 and +3 you have seen in K2Cr2O7. Correct? When K2Cr2O7 react, it have +6. Then it produce Cr2 3 sulfate. Then it will be +3. So these are the two stable oxidation state. Any doubt, guys? Even in case of manganese, +7 is stable, +4 is stable, +2 is also stable. Correct? These three are popular. But example, if you see in KMNO4, KMNO4 convert from KMNO4 to MnSO4, right? So it is converting from +7 to +2. K2Cr2O7 convert from +6 to +3, right? So through this you will get idea what are the stable oxidation states. If I see Pratigya, NCRT is saying that we have two oxidation state +1 and +2. And copper electronic configuration is 3D10 4S1. What should be the common oxidation state in this case?
plus +1.
+1 logically it should be, but actually you will see many time copper 2 positive is very very popular. How is that possible? How, like, we can get electron from 3D10, which is highly stable oxidation state. So +2 is stable mostly in the aqueous solution. Okay, hydration enthalpy is the key factor because you dissolve in water. One interesting comparison if you do from this to P block, if you compare D block element and P block element, Jordan, what is the difference in the oxidation state? Jordan, what is the difference between these two oxidation states of D block element and P block element?
Oxidation state differs from what is +7 all the way down to mine. No, not minus. +1 all the way down to -2. But then P block, it's very limited.
Example. What I wrote, I'll explain you this. If you see group 13, Marinder, what are the elements present in group 13? Mangan, aloo, gajar in thali. These are the elements. You see कि higher elements show +3 oxidation state. Mostly these elements show +3 oxidation state. But thallium is more stable with +1 oxidation state. Okay. If you see group 14, then this. If you see higher elements show +4 oxidation state, but lead have common oxidation state is +2. Here +4 is common. So if you see difference, you have difference of 2. Example, if you see group 15, in group 15 element have common oxidation state. Particle, here. Here bismuth can show +3, but higher element can show +5 oxidation state. So what is the difference? Two difference. How do we know? See, +5 to +3 difference, +4 to +2, +3 to +1. So difference by 2. Every time difference by 2. Understood? But if you see here, if you see the difference in the oxidation state, mostly there is a difference of 1. They can show all the oxidation state. Even if you see in like copper, +1, +2, zinc, +2. So there is usually difference of only 1. That's why I wrote here. D block oxidation state differ by unity, and in P block it differ by 2. I'll give you one more example. Sulfur can show +6, sulfur can show +4. Even in the same element, there will be difference of 2. Correct? Oxygen can show 0, oxygen can show -2, oxygen can show +2. The more common oxidation state differ by 2 in case of P block element. Any doubt, guys?
No,
Then, Chandana, what is the reason why, if you go down the group in the P block, there is a difference of 2? What is the reason for this?
I'm not sure.
Samarth, what is the reason for this?
Is it because we
Inert,
are removing from P elements? Or inert?
inert pair effect. You know, inert pair effect. One pair become inert, not active, not participating in the bonding. That's why you will see there is a difference of 2 from 3 to +5 to +3. So difference of 2. +4 to +2. Difference of 2. Why? Because 2s electron are not participating in the bonding. Pair become inert, and because of this pair become inert, there is a difference of valency 2. Make sense?
So
Any
one
doubt?
of the electrons is inactive.
2.
Okay.
2 electron are inactive. That's why difference of 2.
Okay.
Hey, you can also write at extreme. At extreme, you have smaller oxidation state, but in the middle, higher oxidation state is also there. Any doubt? Just give me a minute, guys. Hello. ठीक है. Yes, guys. Any doubt?
No, sir.
Any doubt? And interesting part is कि in what Barinder, what is the unique feature related to oxidation state in D block element? What is the unique feature present in D block element related to the oxidation state?
Sir,
Variable oxidation state. Variable oxidation state is the unique feature of D block element. It is not present in other. Example, you see कि manganese can show +4, manganese can show +2, manganese can show +7. Correct? Even +6 is also possible, K2MnO4. So there is a lot of variation in the oxidation state. But if you look at the oxidation state of S block element, in case of S block, let's take sodium, you will have only one oxidation state, sodium positive. If you take calcium, it will be calcium 2 positive or potassium 1 positive. Correct? If you see P block, mostly aluminium show aluminium 3 positive, mostly chlorine show chlorine 1 negative. Correct? So variation is less. I'm not saying कि it is zero. There will be variation in these elements also, but variation is less. There is huge variability in D block element. Got it? This is one of the unique feature of D block element, variable oxidation state. Right? And interesting part is very low oxidation state is also possible in the coordination compound when it interact with the other element. Example, you know uh, this nickel. Nickel when react with the carbonyl. So what is happening? In this case, nickel have zero oxidation state. Correct? Nickel have zero oxidation state. So this is possible like CO2, CO8. Have you seen this, Chandana? Mn2CO10. Sara, in coordination compound?
Yes, sir. Rigidly.
Yes. Here we have bridge between the metal ion. So what is happening? Oxidation state is still zero. Though it is forming compound, but still oxidation state is zero. So low oxidation state is also possible. Sanya, are you there?
So one question, sir.
Yes, Jordan.
So Mn2CO10 doesn't have bridge ligand, no, sir. That is the only exception in this.
Mn,
Mn2CO10, like the last coordination compound. There was a question today in the paper which it was sent, sir.
okay.
Uh,
What
it
was your question?
Whether it was bridged or not bridged. They said that Mn2 is not like the third coordination compound doesn't have like the bridging ligand.
Cobalt have bridge. Mn bridge. Yeah, bridge is not there in case of Mn. Let me draw
Oh,
structure because if I draw one manganese, second manganese, manganese can have maximum 7 bond. So CO1, CO2, CO3, CO4, CO5. 5 CO na? Same 5
yes,
CO
sir.
can be present here also. Carbonyl. How many are there? 10? Yes, it's done. It's not a bridge.
Okay, sir.
In cobalt, you have bridge.
2 bridges we have now, sir, in cobalt.
Yes, yes.
Yes, sir.
We have bridge in cobalt, but not in this case. How? Example, if you take cobalt, 1, 2. How many? So there will be 4 carbonyl for each. 1, 2, 3. 1, 2, 3 carbonyl. So still, because bond in this case is limited, so there is direct bond also. There is carbonyl bond also. Correct. So cobalt here have 6 bond. Yes. So here you have bridge. This. Understood. So I think even in NEET we had question related to the bridge from coordination compound. In case of manganese, that is true. There is no bridge, but in cobalt there is a bridge. Got it? Yes. I was asking question from someone. I forgot whom. Sania.
Sir, you want to ask me?
Yeah. So, do you think scandium will show variable oxidation state?
No, sir.
Why?
Sir, because it has less number of unpaired electrons.
Stability of the noble gas. Example, even if you try to make scandium 2 positive, then it will be 3D1. 3D1 will easily lose one electron and convert into the noble gas configuration. So this scandium will convert into scandium 3 positive. Make sense? Understood?
Yes, sir.
So oxidation state is done. So oxidation state in the middle is maximum, and on the each side it will be very less. Okay. And then what is the topic left? We are left with this small topic, color formation. Am I missing someone? There are 7 people. Pratigya, what is the rule for color? Because you cannot remember all the colors. Same thing happened even in case of crystal field theory. You cannot remember color of all the compound. What is the basic rule for the color?
पैरामैग्नेटिक या फिर अनपेयर्ड इलेक्ट्रॉन.
Yes, very good. So if you want to see color in any compound, it should be paramagnetic. If it is paramagnetic, it means there will be unpaired electron. And if you have unpaired electron, what will happen? Color formation will be there. It means if you see scandium 3 positive, it will be colorless. Why? No unpaired electron. Zinc 2 positive, colorless. Why? No unpaired electron. But if you take chromium 3 positive, it will be colored. Which color we are not bothered about. It will be colored because unpaired electron. Barinder, will this titanium 4 positive colored or colorless?
The colored.
Colorless. Because titanium 4 positive configuration will be 3D0. No unpaired electron. Correct? So make sure if there is no unpaired electron, in such situation, it will be colorless. Example, copper 1 positive. It will be colorless. How do we know? Because 3D10 configuration, no unpaired electron. Next, who will tell? Samarth,
Yes, sir.
why D block element form the complex compound?
Sir, empty d orbitals can accept electron pairs, like entire pairs.
Okay. What else?
Sir, more number of orbitals for hybridization is available.
But in case of F, there will be way more. Even in lanthanoid, because in actinoid, understand that there is radioactivity, but in lanthanoid, there is more number, right? There are few reasons. One is metal ion is smaller in size. Metal ion is very small. Second, ionic charge is high, because this is really important. If ionic charge is more, then size will be small. They can easily accept the electron. And third thing you already mentioned, availability of d orbital. Availability of d orbital. So you have d orbital available for the bond formation. So what will happen? Bond will form. Which bond? Coordination bond. Correct? Coordination bond will form. So this is the main reason why. And that is more than enough. Mummy, mummy, phone आवा कुइयां का? Catalytic property. Sara, why D block elements show catalytic properties?
Sir, vacant d orbitals.
Vacant d orbital.
There
But there will be
variable
vacant
oxidation.
p orbital in p block element.
So they have variable oxidation states.
Yes. Variable oxidation state is one of the reason for the catalytic property. Because example, if you see in biology or in chemistry, example iron. You know iron is present in Fe3 positive. When it accept one electron, it will convert into Fe2 positive. Okay. This Fe2 positive donate electron and again convert into Fe3 positive. So because Fe have two variable oxidation state +2 to +3, so it can be act like it can act as a very good carrier. This is very good electron carrier. Reason is this only due to the variable oxidation state. Same thing happen with the copper. If you see copper, you take 2 positive. After gaining electron, it can convert into copper 1 positive. Further, it will transfer electron to some other part wherever it was required and again convert to original 2 positive. So what is happening in this case? Again electron carrier. Understood? Again electron carrier, it can act. Reason, variable oxidation. Okay. Can you give me some example, Sanya, where we use a D block element as catalyst?
So we use it in the uh
Hmm.
we use it in formation of NH3 in
Formation
the
of NH3,
Haber
which one?
process.
In Haber's
Haber's
process.
process.
Which one do we use? Haber's process. Iron. We use iron. Very popular. This is iron. Pratigya, what do we use in the contact process?
Vanadium pentoxide.
V2O5. So reason is variable oxidation state. And Barinder, what this contact process used for? For formation of H2SO4. Chandana, what this Haber process used for? Ammonia formation. Then what happened in hydrogenation, Jordan? Addition of hydrogen in presence of nickel,
In presence
platinum,
of nickel
palladium.
or platinum, palladium, yes, sir.
Finlay divide nickel, platinum, or palladium. Correct. You can
Yes, sir,
convert.
powdered form.
Yes, you can convert alkene
Alkenes to
into
alkanes.
alkenes or alkyne into alkene,
Alkane.
alkyne into alkenes, or you can convert nitro form into amine form,
Amine.
the preparation of amine. Correct. You can use this in the Rosenmund reaction also, but in Rosenmund we use barium sulfate. Correct. Palladium. Yes. In
B
Rosen, what?
barium sulfate.
Barium sulfate. So Rosenmund reduction, if we do, then you have this benzene ring, chloride. What is the reaction, Varinder? But we use palladium also, and then it convert into aldehyde, yes or no? Correct. Samarth, what is Lindlar catalyst?
Palladium?
What?
Palladium.
Palladium.
Yeah.
Palladium and
Calcium carbonate.
it could be calcium carbonate, it could be barium sulfate.
Yeah, so barium sulfate. Yeah, I'm confused with Rosenmund reduction.
Lindlar catalyst. What is the use of Lindlar catalyst?
The reduction.
Of what?
The formation of cis alkane.
Yes.
Hmm.
So when you do reduction of alkyne, so it will form cis alkene. Correct? Only cis form. In this case, you use palladium. You use calcium carbonate or barium sulfate. Both are correct. And here you use quinolone. Jordan, why do we use quinolone?
I don't remember, sir.
It will convert your, what should I say? Poison. It act as a poison. So further reduction can happen and alkane can form. To avoid the formation of alkane and stop only at alkene, we use Lindlar catalyst with poison. Understood? So all these things are extremely important. Any doubt? So uh, whatever reaction you take, mechanism of catalyst is same. It will bind with a reactant, and once it bind with the reactant, what will happen? Example, if you take a reaction, 2 iodine react with S2O8 2 negative. Then iodine will undergo oxidation, convert into I2. This undergo reduction, convert into SO4, not 3. SO4 2 negative. Twice molecule, right? In this case, we use iron 3 positive. So what is the role of iron 3 positive? In the same reaction, first iodine will react with the iron 3 positive and it will convert into iron 2 positive and iodine will form. So what is happening? Iodine undergoing oxidation, iron undergo reduction. Now this Fe2 positive when react with S2O8 2 negative, what will happen? It will convert into Fe3 positive and so we are proceeding same reaction, both are the same thing. What we are trying to convey is how here first iron convert from +3 to +2 and again from +2 it convert into +3. So you get original iron, but it help to convert your iodine negative ion to the I2. Understood? Sania, what is the mechanism of the catalyst? This is the one mechanism key. This is how it happened. But theoretically, how? What is the impact of the catalyst? Which energy is affected? Just give me a
The
minute.
activation energy is affected.
Activation energy. Hello. No, ma'am. No issue. Hello, guys. Anybody who can get print out Xerox now, or like you need soft copy only?
I can't take the printouts right now, sir.
Yeah. You know, if you can't take printout, आइए. So it's okay if you can't take printout, then I will send you in the group and you can do from the phone directly because today you don't have enough time. Okay, so catalytic power is done. Next is D block element from interstitial compound. Interstitial compound. Barinder, what do you mean by interstitial compounds? Example, you have crystal lattice of the metal. Okay. In this crystal metal, you add small atom in interstitial space. Chandana, what is interstitial space?
The compounds.
Space between the big atom. Example, if you see this, though this is very bad diagram. So what will happen? Example, this is one atom of the copper. Okay, all are the atom of copper. I made different size, but actually it should be same. You know there is a space between the atom. This space is known as interstitial space. Space between the atom, interstitial space. In this interstitial space, small atom can interstitial space. So in this interstitial space, small atom can adjust. And if you have a compound mix with the bigger atom in the interstitial space, and what are the atom can exist in between this very small atom? Example, carbon, nitrogen, oxygen, like that. Not oxygen even. Hydrogen. This small atom can exist. Correct. So such compound are known as interstitial compound. A compound which is not containing only pure one type of atom. Of course, compound contain more than one type of atom, but small atom and only in the interstitial space. Okay. But why we are talking about this? What is the specialty? When you understand what is the specialty of the interstitial compound, then it's become easy ki why we are using D block element to produce interstitial compound, because they are not properly ionic, not covalent. They have very high melting point, very high melting point. So if you want to make a material that have high melting point, do not melt easily even at high temperature, you can use interstitial compound. So the special property is the higher melting point. One thing. Then pure atom. So if you take pure metal, they have low melting point usually, but it is way higher than that. So you can use in the tough situation. Even along with the high melting point, they they are very hard, tough, correct? And that's why sometimes they are harder, almost like the diamond. Imagine you want to make a tough material have very high melting point using the small material. Best example is you can use D block. Understood? Any doubt? Even after doing all this stuff, you will see they are conductor. They are conductor. Example, you take diamond. Diamond
So I
made up of
have to
iron.
leave for dinner.
Sure. So this Sania, is this diamond conductor or insulator?
The insulator.
Insulator. So usually you will see any material that have very high melting point and extremely hard like diamond. Let's take diamond example. It is insulator. But if you want to take a material like diamond, but at the same time conductor, best example is use D block element. Isn't it interesting? But like diamond, they are also chemically inert. Chemically, they are inert means they do not react with the many material. So they are very stable. Inert means they do not react. That's why, example, you want to make utensil. So what you want from the utensil? It should be very hard, conductor, chemically do not react and do not produce any harmful chemical, and it should contain very high melting point. Everything is there, so you can use it to make the utensil also. Correct? They are neither pure ionic nor covalent. Correct? Because usually these D block element metal form the ionic compound, usually, not all. And they're not even pure non-metal, so not even pure covalent. So it is nothing. That's why it is interesting. And if you see any specific compound, they will be non-stoichiometric. What does it mean, Samarth?
Sir, I've read the like the atomic ratio is not in whole numbers, sir.
Okay.
It
Yeah,
is in uncommon decimal numbers also. So they can't be compared with stoichiometry.
correct. So, example, usually if you see HCl, here you have one hydrogen, one chlorine. But if you take HCl 0.9, then you will call it as non-stoichiometric. They are not in exact whole number. Same thing happen in this case. Number is not exactly same. That's why non-stoichiometric. Example, if you take Fe3 hydrogen, imagine hydrogen is one negative. All the three iron will have one positive. Each iron will have 1/3, isn't it? Example, if you take vanadium tetrahyd, what tetra? If it is tetra, then it will be stoichiometry. Example, if you take 0.56, this is given in NCERT, ditto same. So what is happening? Not properly stoichiometry. Titanium hydride, but 1.7, not 4. Again, non-stoichiometry. Okay. So you will see these are the benefit of the interstitial compound because they have mixed material of other very strong, very high melting point, good conductor, inert, and these are two chemical property, you can say, kind of. Okay. So interstitial compound is done. Though less question asked from the interstitial compound, mostly board asks this, not the competitive exam. But I have seen question in competitive exam also. Number is less. Example in magnetic property, it's extremely common. Interstitial compound are not so common, but JEE and NEET already asked question from this. And alloy formation. Pratigya, what happened in the alloy formation?
It is a good मतलब protective layer.
Hmm.
जैसे कि मतलब एल्यूमिनियम कोटिंग होता है वायर वाला में.
हाँ.
हाँ.
So alloy means mixture of metal. You can, in the simplest way, can say metal mixture. And when you have this metal mixture, they are uniformly distributed. That's why it look like homogeneous solid solution. It look like homogeneous solid solution. Solid solution means both solute and solvent are solid. Both solute and solvent are solid. How two metal become homogeneous to each other? Like they mix really well with each other. Reason is almost similar size. Almost similar size. Size difference is not more than 50%. It means if you have one element with 100 picometer metallic radii, okay, then another element should be within the range of 115, like maybe 114 picometer. So they can mix well with each other because almost same size, not exactly, but almost same size. Correct. So that's the reason why they can form alloy properly. Alloy mixture means you mix two or more material together and they are properly distributed. What is the special about this? And the special thing about the alloy is they have very high melting point. They are very hard like the interstitial compound. High melting point and they are very hard like the interstitial compound. Okay. Sania, in the steel formation, what are the different D block element used? Jordan, are you there? Sarah, why only these elements? Sarah, why only these elements?
Not sure, sir.
Pratigya, why only these elements?
पता नहीं सर.
Chandana, why only these elements?
No, sir, I'm not sure.
Samarth, why only these elements?
Is it because of unpaired electrons, strong bonding, and strong material?
Yes, because of high unpaired electron, and if you go down the group, we said ki chromium plus 6 is not so stable, but in case of molybdenum or tungsten, it is highly stable, even plus 6. Because why? They form very strong metallic bond, very, very hard. So in most of these elements, there is more number of unpaired electron. Due to high unpaired electron, they can form very strong metallic bond and very high melting point. Region is the property of the individual element. Understood? Example, brass. Example, bronze. Sania, what is the difference between the brass and bronze?
So both have copper as constituent, but along with different metals.
Correct. Brass, bronze medal have SN, tin, and brass have zinc. That's why brass is little bit softer. And you will see the size of copper and zinc is very close to each other. That's why they are homogeneously mixed. Right? They are homogeneously mixed. Are we done with everything in the DNF log? Anything we left from this chapter? Anything we left? Anybody like, did I left anyone? I guess I covered most of the thing. Metal oxide last and oxyanion. Last topic and then we'll be done with the chapter. Oh, you have test at 9 o'clock. I'll finish it. I will not leave anything today. Metal oxide. And when we are saying metal oxide, it means T block metal. Barinder, metal oxide are acidic or basic?
So basic.
Basic. It depends. Non-metal oxide are acidic and metal oxide are basic. So in I think I asked metal oxide. So you were right. So metal oxide are generally basic or amphoteric. You will see these two mostly. Correct. How? Because example, if you take Na2O, if it react with the water, what will happen? It will convert into NaOH. So it is basic in nature. So metal oxide are usually basic in nature. Correct. And most of D block element, you will see they form ionic compound, mostly ionic. Why? Because oxygen is highly electronegative element, so it can form the ionic compound. Okay. Um, who? Chandana. If you increase the oxidation number, what will be the impact on the ionic charge? Ionic character.
Sir increases.
Oxidation number, if it increase, then ionic behavior will decrease. Covalent behavior will increase. Okay. Example, if you see Mn2O7, here manganese have +7 oxidation state. It is covalent in nature, not ionic anymore. So if you increase the oxidation number, then ionic character will reduce. Ionic character will reduce. So Mn2O7 is covalent and it is green. This is even in NCERT, but covalent character is more important for you to understand. Why? Because high oxidation number. Got it? So tell me, can it be acidic also? Samarth, can it be acidic also?
I don't think so, sir. No,
Yes. If you have very higher oxide means higher oxidation state. So they can be acidic in also behavior also. And you will see ki if you can't remember all the oxid. Mm, That's why if you compare any oxidation state, example, if you see manganese 2 positive, it will be more ionic. But if it go to manganese plus 7, they will be more covalent, more acidic in nature. And you know, if oxidation number increase, acidic character increase. Do you remember?
yeah,
Yes or
sir.
no? So this, guys, is very, very important. If oxidation number increase, ionic character decrease, covalent character increase, and acidic character increase. If you understand this, trust me, many of the things are done from the oxide. Okay, I'll give you example. NCRT have given this. If you take chromium oxide, here chromium is +2, it is basic in nature. But if you take Cr2O3, it is amphoteric in nature. Got it? So what is happening? Basic character is reducing, acidic character is increasing. Make sense? Because here it is +3. So when chromium go from +2 to +3, basic character decrease and acidic character increase. This rule is still applicable. Got it? Any doubt, guys?
No,
Example, same thing you can use here. If you take V2O3, V2O4, and V2O5, if you see this is basic in nature, this one less basic compared to the V2O3, and this is amphoteric. So what is happening ultimately when you are increasing oxidation state of the atom from +3 to +4 to +5, you can see your acidic character is increasing. Correct? Your acidic character is increasing. Basic character is Hello, गुड इवनिंग संदीप, मैं थोड़ा क्लास ले रहा था तो करता हूँ मैं थोड़ी देर में कॉल। ठीक है, थोड़ी देर में कर रहा हूँ अभी। क्लास हम प्लान करेंगे पक्का, बट मैं थोड़ी देर में कॉल करूँगा, अभी थोड़ा सा क्लास में था। ठीक है, आज तो क्लास नहीं हो पाएगा, बट मैं कॉल पक्का करूँगा। नहीं, 5-10 मिनट में करूँगा। ठीक है, 5-10 मिनट में मैं ट्राई करता हूँ। अंडरस्टूड गाइस? Just remember one rule, not only in this chapter, even in your P block, same rule is applied. You must have seen कि if you take HClO2 or HClO3 or HClO4, which one is more acidic? Understood? HClO4 is more acidic.
Actually.
How do we know? More oxidation state, more acidic character, more covalent character. Basic character will be ulta. Got it, guys? So this is most important tool when you are going through it. Okay? Higher oxidation state, more acidic. And whenever you are doing acidic and basic, it is comparison. It is always comparison. And low oxidation state, then there will be basic nature. Because usually metal oxide should be basic. Usually it should be basic, but depend upon the metal nature. That's the most important thing. And best example is this, like when we said na, V2O5 is amphoteric. How do we know? Because it reacts with both acid as well as base. It means it is amphoteric in nature. Got it? So one general rule, remember this part. Oxidation number increase, ionic character decrease, and covalent character and acidic character. Very important. I think recently 2-3 questions I've seen in NEET related to this. And I don't think I missed anything important, but there is always scope ki, if you feel ki I won't cover any specific topic, I'll cover for sure. And if you feel ki going through the content and there is any mistake, then let me know. Okay, so chapter is done. Just 1-2 question. You have test. That's why we have to stop here. Means uh, chemistry. Where is the end of block? This done. This done. Not this. Length and node contraction. We covered many questions. We'll go in mid. See, even they ask density, guys. Solve this question. How to correlate with the density, Sarah? बस 2 मिनट ना ना 2 मिनट दो बच्चा 2 मिनट ना सही करे फिर ना रोना भी चाहिए बस ये 2 मिनट में आया मैं हाँ हम्म हाँ ये तो यार लिए कोई नहीं बात करूंगा मैं सारा व्हाट इज योर आंसर if you see density means size is smaller because you know density depend upon the two feature. One is mass, directly depend upon the mass, inversely depend upon the volume. Here you don't have much difference in the mass. Correct? Volume is the major criteria. Along the period, volume or size will decrease, so density will increase. But except zinc. Except zinc. You know, in case of zinc, size increase. So answer will be Sarah. C. Okay, and if you remember, I have covered in the notes, and this is given in NCRT also. Oh, Sarah was not there. Yes, in last class we did this graph. So this graph is given in NCERT as well. It's not like I did this, but graph is important. See, if you see the size of the zinc, it is bigger than the chromium also. That's why you will see zinc density is minimum, correct? And otherwise, it keep on reducing. Pies keep on reducing. Do you remember this graph? And I told you, when it comes to inorganic chemistry or NEET or JEE, both, they ask everything from the NCERT. And if they ask out of NCERT, it's difficult to see. In coaching paper, you will always see a lot of question out of NCERT. Always, in every coaching institute. But in JEE, you will not see many question out of NCERT. Each and every statement, every word of NCERT is important. I mention after every one class or two class. Reason, I want you to just read NCERT, nothing else. Okay, just read NCERT, nothing else. Okay, so I am giving you task for tomorrow, not today. There are 97 question, not 97 question, too many. 207 question. You can't do this many, but you have to cover first 50 question. 2023. Yeah. See. Oh, wow. Order of basicity. Increase oxidation state, acidic character will increase. Samarth, what will be the order of basicity?
Sir, 3, then 4, and then 5. Least would be 5. P2O5.
Option
A.
A. Done. 2023.
Yeah.
And this is ditto NCERT example. Whatever I am teaching from NCERT, same reason. And you don't need to remember even if they give something else. We don't care. We just know कि there is one thing. कि if oxidation number increase, then acidic character increase, basic character decrease. Done. Okay. So I have to do many questions, but limitation because all of you have tests.